Now the next question of ours is a highly important problem because it gives us a hint of the equivalent concept, which is another important concept apart from mole concept in this chapter. We have a solution and we are given that 2.68 into 10 power minus 3 moles of this solution containing the ion An plus. It requires 1.61 into 10 power minus 3 moles of MnO4 negative for the oxidation of An plus into AO3 negative, and the whole process has been completed in acidic medium. We want to find the value of N. Now this question is the most fundamental question of equivalent concept. So we will see what is equivalent concept. First of all, we need to know that in acidic medium, MnO4 negative or KMnO4 performs the following reaction. MnO4 negative plus 8H plus 5 electrons, this gives Mn2 plus. For balancing the 8H plus, we can also write 4H2O. Now the number of electrons which are transferred during this reaction are 5. So the N factor for MnO4 negative is 5. By N factor we mean the number of electrons which are getting transferred during the given reaction. Number of equivalents of any substance is equal to the number of moles of that substance into the N factor. So the number of equivalents of MnO4 negative is equal to the number of moles of MnO4 negative, which is equal to 1.61 into 10 power minus 3 into the N factor, which is equal to 5 in this case. So the number of equivalents of MnO4 negative, which is the reductant here, the number of moles equivalents of MnO4 negative is equal to moles into N factor. Now we write down the equation for An plus. This An plus is getting oxidized to AO3 negative. The oxidation state of A in this is, let us consider the oxidation state of A to be X. So X plus the oxidation state of oxygen is minus 2. So X plus 3 into minus 2 is equal to the net charge on the whole ion, which is equal to minus 1. So X minus 6 equals minus 1, X equals 5. So the oxidation state of A in AO3 negative is 5. So MnO4 negative is oxidizing An plus into AO3 negative, which is having the oxidation state of A as plus 5. So now what we do is, the number of electrons which are getting transferred in this equation is 5 minus N. The number of electrons into the moles of An plus is 2.86 into 10 power minus 3. So this is equal to the number of equivalents of An plus, which is getting oxidized. Now in any redox reaction, number of equivalents of the oxidizing agent is equal to the number of equivalents of the reducing agent, and hence we get 1.61 into 10 power minus 3 into 5 equals 5 minus N into 2.86 into 10 power minus 3. Here An plus is getting oxidized to A plus 5 and MnO4 negative is getting reduced to Mn2 plus. So MnO4 negative or KMnO4 is getting reduced, and hence it is the oxidizing agent, and An plus is getting oxidized, so it is the reducing agent. Hence we equate the equivalents of the reducing agent and the oxidizing agent to get 5 minus N into 2.86 into 10 power minus 3 equals 1.61 into 10 power minus 3 into 5. 10 power minus 3, 10 power minus 3 gets cancelled out, and on solving we get N equals 2. Hence we have got the final value of N as 2. We'll again see what equivalent concept was. Here in our question, MnO4 negative, which was acting as the oxidizing agent, was getting converted into Mn2 plus. The oxidation state of Mn in MnO4 negative is, let us consider this as X. So X into 1, which is the charge of Mn, plus 4 into minus 2, which is the oxidation state of oxygen, is equal to the net charge on the molecule, which is equal to -1. Hence X equals 7. So Mn plus 7 was getting converted into Mn2 plus, hence 5 electrons were getting transferred. So the number of equivalents of MnO4 negative was equal to the number of moles of MnO4 negative into the n factor, and n factor is defined as the number of electrons getting transferred during the reaction, which is equal to 5. Similarly, An plus was getting oxidized to A plus 5. So the number of electrons getting transferred were equal to 5 minus n. Hence the number of equivalents of An plus was 5 minus n into the moles of An plus. Now in the question we are provided with moles of MnO4 negative and the moles of An plus, and we know that during any redox reaction the number of equivalents of the oxidizing agent is equal to the number of moles of the reducing agent. Hence on equating these two we get the final value of n as 2, which is our final answer.